The visuals which you are watching on your screen are not a real gameplay. These has been generated by an AI model which has just been released by Microsoft. This model, which is called as Muse, and that is based on this Wham, is what we are going to install locally in this video, and then we will see how we can generate the similar sort of gameplays. The things are really moving very fast, and it is now only a matter of time before you can make your own gaming experience like this with a lot of ease. Model weights and code for this is already out, and that is what I'm going to show you in this video. So before wasting any further time, let's go and install it. I also want to thank Massed Compute for sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a 50% discount coupon for a range of GPUs, so do check them out. For the purpose of this video, I am going to use this Ubuntu 22.04. You can also use Windows, by the way, same commands will be used there. The GPU card which I am going to use for this video is H100 with 80 GB of VRAM. But look, don't worry about this 80 GB VRAM. You can even try it out on NVIDIA RTX A6000 with 48 GB of VRAM or even less. And I will also show you how you can do that. And I will also show you the real-time consumption of my VRAM. Also, this model comes in two variants, which I will shortly show you. So if you don't want to go with this larger model, which I'm going to use, you can go with the 200 million parameter model too. Okay, so that's said and done. First up, let's create a virtual environment and make sure that you are using Python 3.9. So first, on my Ubuntu system, I'm going to install Python 3.9, and then I'm creating this virtual environment. So let's run it. And Python 3.9 with the virtual environment is installed, and you can see that it is showing us the version. Next up, let's git clone this Wham's repo. And the repo is cloned. If you just check its content of this, you will see that there are a lot of files which are present there. We need to run this setup_local.sh. Let me clear the screen, and now let's run this. I'll just say /, or you can use it with the shell. So what this command is going to do, this command is going to simply create a virtual environment, and then it will install all the requirements. So let me run this. So it is doing it on the basis of 3.9. That is why we installed it. So let's wait for it to install everything. While it does this, let's talk a bit more about this model quickly, as what exactly this model is. So as I mentioned earlier, this model, which is based on Wham or World and Human Action Model, is a generative AI model developed by the Game Intelligence Group at Microsoft Research in collaboration with TAIEX and Ninja Theory. Muse or Wham is designed to generate dynamic gameplay sequences, including visuals and controller actions based on prompts. Wham or Muse predicts tokenized game visuals and controller actions given a prompt. It encodes game visuals into discrete representation, and then it performs next token prediction, and that it is using the transformer as a backbone. It was trained on an anonymized gameplay data from 28,000 players, which is quite amazing. It can produce coherent and diverse gameplay sequences. It demonstrates an understanding of the game environment and temporal relationship, which is crucial for the gameplay. It also enables creative iteration and exploration in game development. And as I mentioned earlier, there are two variants of this Wham. One, this is Wham. So if I go here and then scroll down, you will see that we have two variants there in Wham, which you can check on their Hugging Face page. I'm just trying to search it. There you go. So if I click on this Wham, so this is 200 billion, and then we have the 200 million parameter, and then 1.6 billion parameter. So I'm just going to go with the 1.6 billion parameter. If you don't have that much space, you can simply use the 200 billion one, which is quite small, I would say. So that is good. Let me also introduce you to the sponsors of the video, who are Camel AI. Camel AI is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents, with applications in data generation, task automation, and world simulation. And I will drop the link to the website in video's description. Okay, let's go back and see what is happening. It is still running. It is going to take a bit of a time. And all the prerequisites are now done, which is quite good. Let's clear the screen. And also, if you go to the models directory, you will see that it has downloaded this both models 200 million one and the 1.6 billion one. So whatever your VRAM is, you can use either one of them accordingly. So I'm going to go with 1.6 billion one here. Okay, before now we run it, we also need some sample data to create the game visuals. For that, what Microsoft has done, they have provided us this dataset, which is bleeding edge gameplay sample. So I'm going to download this too. You can download it anywhere you like. Maybe I'll just create a new directory. I'll say, I'll just call it game data or whatever. And then you can either, I'll just go in, and then here I'm going to git clone that set. So all I'm doing it, I'm just git cloning this git clone and all that stuff. So let's try it out. And it has downloaded it. If I do ls here, you will see that this is a bleeding edge one, and it contains a tiny sample and a lot of other stuff. So let's keep it like this. I'm just going to do pwd to grab the path here. Okay, so let me copy it and clear the screen. And now in order to generate the gameplay sequence, all you need to do is to run this Python 3 from the root of this Wham repo, run underscore dreaming.py, give it the model path. So you see that I'm just using the 1.6 billion here. You can go with 200 million. And the data paths, I'm just going to go in the tiny sample directory, which contains a tiny sample. So what this code is going to do, this code is just going to do a very simple trajectory. So it will be using the tiny sample set for only 4 trajectories for initial exploration, and of course you can expand it, you can give it as many data as you want. If I quickly take you there, you see this is a tiny sample, and it contains some of the mp4 files, some of the npz files. So this .npz file contains a number of entries, like encoded decoded ground truth images, like original context image, and then it uses a vqgan, and then we have this dreamed images, the sequence of all dreamed images, just keep it as is. And then this is mp4 file of the context data plus dreamed images for easy viewing. Okay, so now we know what sort of data set we are using. You can create similar data set for your game sequence and go from there. Now if you are just running this from tiny sample, it just as per the Hugging Face repo card, or you can easily use it with 5 to 6 gig of VRAM by just running it on this tiny sample data set. So let me quickly run this. So it is processing it now. Let's wait for it. And while it is running, you can see that it is consuming just over 4 gig of VRAM. How good is that? But it might go up as it progresses. So I'll just run it again, and you see that it has now gone to 22 gig of VRAM, and I will keep monitoring and keep you posted. Meanwhile, you can see that it is generating the dreams of 4 segments, because it has found around 4 files there. So let's wait, and hopefully it is going to not take too long. But if it would be, I'll just let you know. And it is progressing well. It's been 10 minutes, I would say, and the VRAM consumption is staying just over 22 gig of VRAM. So make sure that you have that much space. I don't think so it is going to go over that. And by the way, while it runs, it is going to start putting in whatever artifacts it is generating here in this dreaming output directory. And I'll just show you, it does look like this. So I'm just going to play this one for you. And this is our game artifact it has generated so far. And then of course you can have your own images, you can have your own context and example, and then you just provide it like that and it is going to create a gameplay for you. And while I was talking, it has created one more, so let me also play that one for you. There you go. So this is a second one, this is a first one. I'll also play that for you. Pretty interesting. And there you go, it has generated all the four dreams or basically the gameplay. So if I just go here and then this is a dreaming output, you can see that I already have showed you this one. This is the first one. This is the second one. I'll also make it slightly bigger. They're very small, but of course we can knit them together. This is the third one. This one is the best, I would say, so far. Let's check out this one. There you go. So really very, very high quality, I would say. And I just did it in front of you in real time. And this is just a start, and I really can't imagine what this year has in store for us, because I think we should be ready for a treat. So that's it. I hope that you enjoyed it. Let me know how you go. And as I said, if you have lesser VRAM, then go with the 200 million parameter one instead of 1.6 billion one. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.